So welcome, this is the Just a Lab. And this is the humidity inside the Just a Lab. As you can see, it's around 70%. And this is the Grove Beginner Kit for Arduino. Now, humidity is a measure of how much moisture there is in the air. And if it's too high, it can be quite uncomfortable, as well as cause other problems. So in this video, I want to try to use this kit to try to help me build a Peltier dehumidifier. So let's get started. So I first want to disclose that this kit was sent to me for free from Seed Studio. Yes, this is actually my first free product gift, so I have actually officially made it on YouTube. And I was a bit surprised because they told me they checked out my channel and they liked my videos, which I found was kind of suspicious because most of my videos are trash. But again, I'm no stranger to Seed Studio's products. I haven't used their ZAO in my PC fingerprint logging project. And I'm not going to lie that this kit also didn't disappoint. I've been using it for the past week and I'm going to say that this is probably one of the best kits on the market right now, at least beginner kits for Arduino. And you don't have to take my word for it. In this video, I'm going to kind of show you exactly what you get in the kit. I'm going to use it actually for my project today, which is a Peltier dehumidifier. So they really advertise this as an all-in-one kit. There's no breadboard, no soldering, no wires needed. Well, it has wires. The reason why they're advertising it as that is when you get most Arduino kits, like this is from the Arduino starter kit, it comes with a breadboard, and you normally have to use like jumper wires. So I actually have, a beginner Arduino kit here. I know it will come with an Arduino, it will come with a breadboard, it will come with a bunch of these jumper wires here, and these can be quite annoying to use. And they decided, here what, let's try to remove that barrier to entry so you get started straight on to the coding and to the sensors and inputs and output aspect of Arduino. So when you open it up, you get this beautiful kit. On the box you have a kind of Arduino cheat sheet here for some of the programming and syntaxes and language references. As you can see here, they actually describe how the box itself is also a case. I actually took this out already before, so that's why this come off, but originally comes locked in there. To the right, you have the USB cable here. To the left, you have these cables. Now, you get 6 with it. You don't need to take any of these modules out of this kit. They are breakaway, so you can break them away, but I recommend keeping them here as long as you have this kit, unless you really need to use them for specific projects. But again, this is actually a really good teaching tool. So if I was to build over this kit with what I already have, I know I would need an Arduino UNO and a breadboard. I would need a temperature and humidity module, the accelerometer, barometer, light sensor, sound sensor, potentiometer, button, LED, a buzzer, an OLED display, a bunch of resistors, PCB ruler, a bunch of jumper cables, and this could simply change. So I think that's really, really cool and really, really simple and gets you started with coding. One downside I don't like about this board is it actually doesn't have a 5-volt regulator on it, like how this has a DC jack, which I find is a bit of a bummer because I like to normally put like a 9-volt battery to power my Arduino or something else to power the Arduino. So you actually have to power it from the USB cable or via power bank. So let's talk a little bit about how I plan to use this kit in this project. I'm really looking at that temperature and humidity sensor as the main focus, as well as the display, because I want to display my temperature and humidity of the room as the device is on. That button and rotary potentiometer may come in handy, as well as the LED, and definitely that light sensor, because what I want is I want this thing to only come on when I'm not in the room, and a big indicator of me not being in the room is the lights are off, and this room kind of has a kind of steady darkness. So I can use the light sense to kind of determine whether someone's in the room or not, and then it will put on or put off the device. Now the device itself, so I have a bunch of cooling fans here. So if you checked out my PCBWay video, I got some new Peltier coolers / heaters. And how these devices, this thing, when you scratch them together, it kind of scrolls my blood. Now how these work is that when you send a current through it, it uses something called the Peltier effect, which kind of moves charges between the two plates to give you a hot and cold side. Obviously, if you keep it on or you don't cool the hot side, there's like a thermal runaway where the whole thing starts to get hot, which I obviously want to try to avoid. I also have thermal paste and stuff to have this. But the idea is the cold side supposed to get cold enough to condense water in the air, and then I will drip it in a bucket. For the bucket, I bought this, which is a DampRid Moisture absorber. This didn't last a week. It got full instantly, and they actually have these like replacement tablets to go inside of it. But I found it's kind of costly to keep buying those to help manage the humidity in here, as well as the water that it produces. Well, they recommend you throw it down the toilet, but I took a little bit just to test it and throw it on some grass, and it completely dried out the grass and killed it. So that isn't something I like too much, whereas if I use the condensation from the Peltier, that water is going to basically be clean and pure, which I can use it to water plants and stuff afterwards. So, but yeah, I don't want to have to keep paying to buy tablets for this. And I also don't want to have my AC running all the time to manage the humidity. I think this Peltier device is going to be the next best option. So what I'm going to do first is I want to kind of test to see how this Peltier device works. And then I would build a code and circuit to control this and the fans via the Grove Beginner kit. So I have this really big computer CPU cooler. I also have a smaller one that I will probably use in the final product. And then I have the Peltiers. So these are TEC112706. Now I want to test it first with this CPU cooler. And the reason why is I want to just see, I think this one would give me the best heat dissipation. So I want to see exactly how cold it's going to get. So I'm going to just do a quick test just to see which side gets hot and which side gets cold based on the positive and negative. So I'm going to just connect black here to negative, and then that gets cold really fast. Alright, so this is the hot side. So I'm going to just put, so the side without the words is the hot side. Bear that in mind, and this thing gets really hot really fast. So just be careful if you're using this like how I am. And so I made a little jack here for the fan based on the pinout. I'll put that there. So once the Peltier comes on, the fan comes on.
A few moments later.
Alright, so I have quite an elaborate setup here. I have a lithium-ion battery that can provide like as much current as it needs. And I'm going to apply some thermal paste on this before I put the CPU cooler on it. I'm going to just press that down there. That side has thermal paste underneath it. So right now it's just an exposed top. Let's see if this does the job. I realize that I may need to put something to hold them together. Right, so I just zip tie this thing together. Alright, so current, temperature, Peltier. Moment of truth is, I'm gonna put this in here. So this fan comes on instantly, it's on full. Alright, so I think this thing is working a little too good, and I'm really surprised. Peltiers are really cool. The lowest temperature recorded was about 11.4 degrees Celsius. That's on top. All that is water building up on this thing already. Like, all that is water. And it's cold. It's like really, really cold. Like, I can just rub my hand on this, and all that is water. Let's see if I can collect some of this water. So yeah, in about the 10 minutes that this thing has been running, it has collected about that much water. There's still a little water on it itself, but I guess as it collects more, it will drip off. I'm going to try this one next, just to see. I can supply more than 3 amps from my bench top power supply. So I'm going to switch over to that also. So that's pretty secure there. And in 3, 2, 1, start. So immediately it's pulling about 3 amps, 3.02 amps. Alright, so I've had this here for about 10 minutes and it has collected a lot of moisture on top of here. Like there's a lot of moisture. I'm not sure if you can see that in the camera. The surface temperature on top of here is about 18 degrees compared to about 12 with this one. So this one is definitely getting much colder, I guess because it's a smaller surface area. Actual surface of the Peltier device I measured about 10 degrees Celsius. So this one is a little bit more closer to the top of the Peltier. On the hot side, we're getting about 32 degrees Celsius. Current has stabilized at 2.9 amps, which correlates with exactly what the other multimeter was saying. That's on my digital power supply. With the more surface area, it is collecting more water, but I think this did a better job with the collection because I got a lot more water faster. So I'm going to try it with this smaller heat shrink, right? And the reason why is because I want to fit it inside of here, and it's going to be very difficult to put this huge thing inside of here.
That's what she said.
Actually, so like you can just compare the sizes here. This is almost the exact same size as this. And the idea that water should fall down into this bucket below. So you can actually see here as like a bay for water to fall in and collect in this bucket here. But it is collecting water. Oh, look, it just dripped. I might use this plate just because it's much it's more feasible. Hey, this thing is so wet. Watch it out. Alright, so there we go. It's screwed in. I realize I can just have this. Right, so I need to cut off a little bit of this. Right, so this is why I like this heatsink better for this one, because it's nice and wide and it goes right across the groove. So this is about 13 centimeters long, about 4.5 centimeters high. Alright, so I've been away for about 20 minutes and I came back to check on it and I missed when it dropped, the first drop. I'm seeing 3 drops so fast. In about 20 minutes, that's like 3 little drops of water. I think this one would have done a better job because it's smaller. But the reason why I like this heatsink for, it's better suited to go onto this DampRid bucket. So I don't have to 3D print anything and it just goes on it like that. I'm gonna probably bring it down about 2 centimeters. Look at next strip, next strip. Two. So hopefully, oh look at drip. Another drip, another drip. It dripped. It dripped right there, and that should give us exactly what I want there now. Hopefully. I don't know. Let's see. Yeah. So that's sitting nicely there. That's sitting nicely there. And that is really, really nicely in there. Right, so no more calcium tablets, no more DampRid reusable products. I got rid of the DampRid. Air inside, and then that air flows over. Oh, look, more water is dropping. I'm so excited. Alright, so before I head to coding, I kind of went ahead and actually hook up all the wires to control both the Peltier and the fan. So I added a dual relay, and these are rated at 10 amps, which is more than enough for the Peltier, which pulls around 3 amps. I've used these screw connectors to join the wires. I've added a DC, I think this is a male, and then I've also bridged this to give me a USB micro cable that will then be able to plug into the groove with an inline 5-volt regulator, buck converter, That's about it for the Peltier. So 2 wires will go to 2 GPIOs on the Grove, and we should be able to control both the fan and the Peltier on and off. Okay, so the finished circuit is pretty simple. So I have the relay on top of here. I just used some tape to stick it down. And then I made this cable with one of the cables that came with the Grove kit. I just used some jumper wires. So it just goes from the relay to the Grove cable that came with the kit. And then this goes directly into the D7 header on the Grove kit. Now the code for this project is pretty simple. I actually did all the exercises from the Grove Beginner Kit for Arduino on the Seed Studio website, well, their wiki. And they have a bunch of projects kind of explaining how to use each module. The only sensors I'm using for this project are light, the LED, the buzzer, the display, the rotary potentiometer, the button, and the temperature and humidity sensor. So I actually used their actual code to help build my code. In the code, I actually added a bunch of stuff here to do limits. So the code is designed to have humidity control, temperature control, and light control, as well as button control. If the humidity goes below 45, it should cut off, and then if the humidity goes above 50, it should come back on. So that's that. I'm gonna add a timer in the future, so it will only run for a certain period of time, like let's say 8 hours or 12 hours. Display update milliseconds. This is how often or the frequency of information in the display will be updated. And then I have a warm-up time and a cool-down time. I realized that this particular fan has like a 3-second spool up to get to maximum speed. So I let it reach maximum speed before I put on the Peltier, as well as when I take off the Peltier, I leave it running for about 10 seconds after, just to make sure it cools off the heatsink. There's no real other reason for that. I don't know any kind of science behind it. I just find it's kind of cool to have it staggered. It sounds scientific, but it really isn't. So to start the device, it comes on in its off state. You press the button and the LED will come on. If the light is more than the rotary encoder, then it will do nothing, because right now it should be off. The light is on in the room. Somebody isn't present in the room. Now, if the light was to come off, right, the fan will come on because the board is on. The buzzer will beep and it'll put on the Peltier. Now, if I was to put on the light, buzzer will beep. It will take off the Peltier, and then a couple of seconds after, the fan will come off also. So the fan came off, right? And then it's displaying humidity and temperature. Now, because it's very difficult to control the humidity. I can't really show how it does the humidity control, but it does it. Just take my word for it, it does it, right? So it's morning time by me, and I had this thing running whole night. I have my relays on top, and I have my DampRid modified Peltier dehumidifier. There is liquid, which is like really like I'm so happy that it has liquid in it, because I've been really disappointed if I woke up this morning and it didn't have any liquid in it. Now I set the code such that when the light comes on or it gets bright, it should cut off, but I realized that it was still on this morning even though it's bright outside, and that's because I forgot to take into consideration the cover. So I have to probably lower the sensitivity of the light, so it just cut off there. But as you can see, the power light is still on, which means it's still on, and I could press this button here and take it off. So that's the water there. So for the past 8 hours, we got about 25 milliliters we got last night, which is pretty good. I don't know. I really don't know if that's good for moisture taken away from the air. Yeah, so as you can see, there's no set of real fanciness going on here just yet. Again, it was just an initial prototype, and that's a really good thing about this. Well, I would call it a development board, but they call it a beginner kit for Arduino. where I can play around with a lot of modules and systems and not worry too much about wires and getting things messy. So yeah, some future updates for this project would be to probably add a Wi-Fi module, and that will allow me to track things like the humidity and stuff over a period of time. I could push that data to Thingiverse, or I can do a data logger, but then I'll also need a real-time clock. And obviously a float sensor inside of here in case it ever gets filled up with water. For whatever reason, I don't see this filling up with water that much because it's not that fast. But I think I still appreciate the fact that it does take moisture out of the air. But yeah, it's important because it's water I'm dealing with to have a float sensor or something inside of here such that if the water ever goes above a certain amount, cut it off one time to avoid any kind of overflow. Again, this thing took 8 hours to give you 25 milliliters. So again, that's it for this video. I hope you liked and enjoyed this project. If you have any questions, suggestions, let me know in the comment section below. Do consider subscribing. And that's about it. So see you in the next video.